Measures for describing data. The previous class looked at ungrouped data on how to come up with the measures of central tendency, like the arithmetic mean, the mode, the median, and also measures of position for discrete data that is countable. So we discussed that data can be quantitative or qualitative in nature. Qualitative data is descriptive in nature, whereas quantitative is quantifiable. And we looked at the subgroups of each, stating that quantitative can be discrete or continuous, whereas qualitative can be ordinal and or nominal. So now we get to what we call grouped data. So back to our pictograms, we identified important pictograms like the histogram, which has continuous data for quantitative information. And we also looked at the bar chart, which had what? Discrete data, which was separate. We also looked at a pie chart for those of us who buy pizza, you know that it's in a circular form. We also defined how a stem and leaf diagram looks like, a box with plot. So stem and leaf diagram, we defined it as looking like this. Here we have our stem, and here we have our leaf. Okay, so it's possible to transform data which could be grouped to grouped data. So we could have 0, 1, 11, 0, 2, 0, 5, 11, 12, 10, 13, 22, 1, 20, 26. Thirty-four, 30, 30, 45. Right. So let's come up with a stem and leaf diagram using this data. So we can identify our stem and leaf as follows. The leaf is the last number. So we have numbers that start with zeros, numbers that start with ones, twos, threes, and fours. So for the zeros, we have 0, 1. So instead of writing 0, 1, there's already a 0 there. So just put 1, the last number. Then we also have 0, 2. We arrange them in order. And what? Finally, 0, 5. On the ones or the tens, help me. Which one is the smallest on the tens? 10 itself, 1, 0. Then we got what?
11.
11, 2, 11, 1, 1. Okay. Then 12. And finally, 18. Let's go to the 20s. What's the smallest in the 20s?
Collins, I think I need to understand how you are breaking off, say, 11, starting from 11. Instead of indicating
There's already
11,
one
you've
here.
inserted 1.
There's already 1 there. So 1 and 0 makes 10. 1 and 1
Okay.
makes 11. 1 and 1 makes 11. 1 and 2 makes 12.
Okay, that's clear now.
So on the 20s, we have 20. So 2 and 0. The next one is what? 22. So that
2.
2 and 2, and another 2 and 2. Then
We have a 6.
26, correct. On the 30s, we have what?
A 30, so we have a 0 there.
Mm-hmm.
So we have 2 30s, so 2 zeros, yeah. And a 4.
Mm-hmm. And on the 40s,
Then we only have 45, so just a 5.
correct. So this is a stem and leaf diagram. So you can put a key there just to guide you to say 12 means what? 1 and 2. That's something to understand. All right, so let's now use the data that we have to identify the ungrouped data first of all before we group it. So what is our range? Who remembers how do we find the range? The highest value minus what? The lowest value. What is our highest value?
45.
5. And the lowest value?
1,
1. So what is our range?
44.
44.
4. Okay, the mid-range. How do we find the mid-range? We add them and divide by 2. 45 over 2 is 46 over 2. What do we get? 23. The mode. How do we find the mode? The most frequent. We have these most frequent numbers here. It's not like one separate line, they're consecutive. So we have what? 11, 22, and what?
And 30.
30.
Yeah. All right, so are we clear so far? Before we proceed, are we clear so far?
Yes, we are.
All right. Then let's go to the quartiles. Okay, so now we go to the quartiles. Quartiles, who remembers how to find the first quartile? First, we need to find our n. There's first quartile, the second quartile, and the third quartile. Our n is what? Count them 1, 2, 3, 4. 1, 2, 3, 4. So our n is 16 in total. Okay, so how do you find the first quartile? Who remembers?
The first quartile is the quarter of n.
So a quarter of n, quarter of 16 is 4. So what do we do with the 4? When we find the four number?
Add the next number, divide by 2.
So fourth number plus the fifth number divided by what? By 2.
2.
So let's go and identify the fourth number and the fifth number since we already have a stem-and-leaf diagram. So 1, 2, 3, 4, and what? 5. So which two numbers are these? 4 and 5. Which numbers are these?
10 and 11.
Excellent. 10 and 11. Not 0 and 1, no. 10 and 11. So when we average these two, we get 10.5. I'm happy. Second quarter, somebody else? How do we find the second quarter?
Half
Half of what?
of number.
Of n, which is what? 8. So when we find 8, what do we do?
Again, we add the next number.
8 and the what?
The 9.
9 divided by 2. So help me identify which one's the 8th and which one's the 9th. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. What two numbers are these?
13 and 20.
Yes, 13 and 20. 13 plus 20 divided by 2, which is at 33 divided by 2. What do we get?
16.5.
16.5. All right. Then finally, 3/4 of what? N. 3/4 of 16. What do we get? 12. So what does it mean if we get a 12?
12th and 13th number added
And divided by what?
over 2. 2.
So this was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and it's supposed to be 12 and 13 or 13 and supposed to be what? 12 and 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. What two numbers are these?
26 and 30.
26 and 30, correct. 26 plus 30 divided by
13
2.
over 2.
256 divided by 2, which is what? 2 carry 1, 28. Okay, so the difference between the third quarter and the first quarter is called what?
Interquarter.
The interquarter range. Good. IQR. So 28 minus 10.5. What do we get? 17.5. So to find the extreme value, the lower extreme value, we do Q1 minus 1.5 interquarter range. The upper extreme value, Q3 plus 1.5 IQR. So here we're going to have what? The lower quarter was what? 28. And the upper was what? The lower quarter was 10.5. And the upper was what? 28. So to the lower we subtract, to the upper we add. That's the difference. 1.5 times the quarter range, 17.5.
Collins,
Uh-huh.
I think I'm lost where you were getting the 1.5
1.5 is
for
standard.
the. Oh,
So
it's standard. Oh, okay.
yes. So this 1.5 is standard. It's added, it's for the correction term. 1.5
Okay.
IQR we subtract from the lower, 1.5 IQR we add to the upper. So here we're going to have what? 10.5 minus 1.5 times what? 17.5. So here we're going to get negative 15.75. And here we have 28 plus 1.5 times 17.5. We're going to have 54.25. Right. So far, any questions so far? So now the range is okay between negative 15.75 and the 54.25. So are there any outliers in this case? We're going to, based on this, do you have any outliers? Here, our smallest value was 0.1, and our highest value was 45. It all fits inside here. negative 15.75 and 54, so there's no outlier. Okay. There is no outlier. Are we together? So how do we draw the
Yes.
stem diagram? Okay, the box Whisker plot. Okay, we have the minimum value of x, and the maximum value of x. Q1, Q2, Q3, and the maximum value of x. So here we had what? 0, 1, we have 45. Q1, Q2, so 10.5, 16.5, and 28. 10.5, 10.5, 28. Then the outlier here, the x value 0 is 54, and here negative 15. So if you want the film cut, so this is what we call the box Whisker plot. Okay. Anyone lost so far?
Not really lost, but just to find out the significance of this box Whisker plot in research.
So box Whisker plot, very good question. Helps us identify values that could be extreme. You're conducting a questionnaire and you're asking for maybe an average waiting time that people have in a bank. And most of them are giving you maybe 15 minutes, 10 minutes, 13 minutes, and somebody just tells you 30 minutes, an outlier. An outlier will give you an odd range so that when you're sorting out data in research, you're able to clean it out to something that is well distributed. So there are certain responses that are odd and extraordinary that you could say, yeah, it's not within our range. Is that clear?
Yes, it is.
So I want you now to try this question. Just identify whether there's an outlier, find the quartile, just 3 things. Draw the box Whisker plot, identify whether there's an outlier. I'm going to give you 5 minutes. Okay, so we're given a question where we are told the following: list the number of days that 15 houses in particular are waiting to be sold. So we have these numbers here. So we've been asked to come up with a box Whisker plot and identify whether there's any outlier. So first we need to find the quartiles. So the first quartile, Q1, is a quarter of our N. Now N here, how many are these ones? Our N was what? 15. All right.
15.
So a quarter of 15 is 3.75. So what we do when we find 3.75? We round up.
Round it.
So 3.75 becomes what? The 4th position, right?
Yes.
Then fortunately, they're already rearranged. So 1, 2, 3, 4. So our Q1 is what? 36. So this is 36. Who found the 36?
I did.
36, yes.
Okay. Then the upper quartile, okay, or the median is half of what? 15, which is what? 7.5. 7.5 means we are running up to the 8th figure. So which one's the 8th position? 1, 2, 3, 4, 5, 6, 7, 8. So 50. Did you find 50 as second quartile?
Yes.
And third quartile is 3/4 of N. So 3/4 of N is 11.25. We round up, which is the 12th position. 12th position is 64. Did you find that?
Yes.
So the interquartile range is the difference between the upper quartile and the lower quartile. So 64 minus 6, so 28 days. Did you find that? So to find the lower limit, it's Q1 1.5 IQR. So Q1 was 36, that's 1.5, times 28. So this is 36 minus 42, which is negative what? Negative 6. So that is on the lower part, 6. The upper limit, you use the upper quartile, which was what? 64 plus 1.5 IQR, which is 28. So find 106. So 106 is the upper quartile. So can we identify any outliers in there? The outlier is 115. So 115 is what is outside range. So that is our outlier. Did anyone find that? Trisha, did we calculate the outlier?
I did, but I missed it on the IOR.
IQR, interquartile range.
Yes. So instead of subtracting, I used the addition sign.
Oh, okay. All right. So that's a principle that you're supposed to use on what we have just learned. So lastly, we go into grouping data. That data can be classified into grouped data. So we came up with the frequency distribution table. So we learned that here we can have what? 1 to 5, 10, 15, 20, 6, 11, 16. The frequency here. So we will have frequency maybe 4, 8, 6, 2. So when data is put into groupings, we call this grouped data. This data can be filled in what is called a frequency distribution table. So our figures here, the 4, we put it here, we add it to the 8, we get a 12. Wait, 12, we add to the 6, we get what? 18.
18,
18, we add to the 2, we get what?
20.
So here our n is what? 20. So the height is the distance from here to here to here to here. So our height in this case is what? It's 5. Then you can come up with what we call the midpoints. The midpoint is simply adding the lower bound, the upper bound. So 1 plus 5 is 10. 1 plus 5 is 6 divided by 2. What do we get?
3.
3. 6 plus 10, 16. 8. So you discover that the distance from here to here is the same 5 height. So the shortcut, just add the 5 throughout. So 8 plus 5, 13. 13 plus 5, 18. Or you just do the same way we're doing. Just add this plus that, 16 divided by 2, 8. 11 plus 15, 26 divided by 2, 13. 16 plus 20 divided by 2, 18. Then here we're squaring. So 3 squared is 9. 8 squared, 64.
64.
18 squared,
96.
169.
9.
18 squared, 324. Then we now find the f of x and f of x squared. So in this case, you just multiply the frequencies with the x's that we had here. So column 1, column 2, column 3. So here is column 1 times column 2, column 1 times column 3. So what we do here? Like, what is
4 times 3,
is 12?
12.
Again, 4 times 9, 36. The mistake people make, they want to square these to get this answer. You just do it individually. 8 times 8, 64. Again, 8 times 2 is 512. Here we have 6 times 13 is 28. And 6 times 169, 10,
40.
and here 2 times 18,
36.
6, and 2 times 324,
8.
38. And you total up here 4 plus the 4.
Hi, Collins.
Yes.
I'm lost a bit
Okay, where are you?
on the fx squared. Want to just on the fx squared. Want to just squaring 12 by 2. Want to squaring 12 and everything. How are you finding the 36?
Don't square these to get this. So I've given you this column 1, column 2, column 3. So 4 times 3 is 12. Again, 4 times 9, 36. Then 8 times 8, 64. Again, this is a starting point. 8 times 64, 5, 12. 6 times 13, 78. 6 times 169.
I get the idea of how you're finding the
Unless it was in
fx.
brackets like this here, that's when you're squaring out of this to get that. Okay, but this is f times x squared. So f times x squared.
Oh, okay, I get it now.
All right. So this is summation of f of x. This is summation of f of x squared. Are we following?
Yes, we are.
So the mean for group data now changes from the formula we're using. Summation of fx over n. So 190 over what? 20. What we get? Right. And here the variance also changes. Summation of fx squared minus fx to the power 2 over n, everything over n minus 1. 210 minus 190 squared over 20, everything over 20 minus 1. So 190 squared divided by 20, so 22, 10 minus divided by 19. So the final answer is 21.3. So I'll end here for now. Your homework will just be on these 2 videos I've done. They'll be a little bit tricky, but based on the exam papers you have seen before. Please don't embarrass me. Take your time. And I will need this work by tomorrow. So we'll be going to another session